All right. Hi there. Welcome back. So, we are now going to address Z file system or ZFS. So, you want to get to it? I do. Let's do it. The Z file system. This is a free and open source logical volume manager built by Sun Microsystems for use in their Solaris operating system. Now, some of its most appealing features include some of these: endless scalability. Okay, so it's not technically endless, but it's a 128-bit file system that's capable of managing zettabytes. That's 1 billion terabytes of data. So no matter how much hard drive space you have, ZFS will be suitable for managing. We've also got maximum integrity. So everything you do inside of ZFS uses a checksum to ensure file integrity. You can rest assured that your files and their redundant copies will not encounter silent data corruption. Also, while ZFS is busy quietly checking your data for integrity, it'll do automatic repairs anytime it can. Now, drive pooling is a great thing. The creators of ZFS want you to think of it as being similar to the way that your computer uses RAM. When you need more memory in your computer, you put in another stick and you're done, right? Similarly, with ZFS, when you need more hard drive space, you put in another hard drive and you're done. There's no need to spend any time partitioning, formatting, initializing, or doing anything else to your disks. So when you need bigger storage pool, just add disks. RAID. Sure enough, ZFS is capable of many different RAID levels, all while delivering performance that's comparable to that of hardware RAID controllers. So this allows you to save some money, make setup easier, as well as having access to superior RAID levels that ZFS has improved upon. What about installing ZFS? Well, since we're only going to be covering the basics in this video, we're not going to really be doing any installing of ZFS as a root file system. This section just assumes that you're using ext4 or some other file system and would like to use ZFS for some secondary hard drives. Okay, so here are a few of the commands for installing ZFS on some of the more popular Linux distros. Solaris and FreeBSD should already come with ZFS installed and ready to use. So here we've got $sudo add-apt-repository ppa:/ZFS-native /stable. Also, $sudo apt-get update, $sudo apt-get install ubuntu-ZFS. Now, as we continue along with this video, we're going to be using Ubuntu because it seems to be the number one choice for a lot of Linux users. You should still be able to follow along, though, no matter what, because the ZFS commands are not going to change across any other distro. Okay. Now, installation does take quite a while, but once it's finished, just run $sudo ZFS list and make sure it's installed correctly. So you should get an output that looks something like this. So we're actually using a fresh install of Ubuntu Server right now, and we've only got one hard drive. So now let's say we put 6 more hard drives into our computer. What do we do? I'll run $sudo fdisk-1 pipe grep error. And this is going to show us the 6 hard drives that we just installed. So they're currently unusable since they don't contain any kind of partition table, right? But like we were talking about before, one of the really nice things about ZFS is we actually don't need to bother with partitions, but you can if you want to. So, in fact, why don't we just start by taking 3 of our hard disks here and putting them in a local storage pool by running the following command. $sudo zpool create -f geek1 /dev/sdb/dev/sdd. So what you've witnessed is the zpool create command, and we use that whenever we're creating a new storage pool. The -F overrides any errors that occur, such as if the disk or disks already have information on them, and Geek 1 is the name of the storage pool. And then this here, the dev SDB, dev SDC, dev SDD, are the hard drives that we put in the pool. So after you've created your pool, you should be able to see it with the df command or sudo ZFS list. And what you're looking at is the Geek 1 has already been mounted and is ready to use. Now, if you want to see which 3 disks you selected for your pool, you can just run sudo zpool status :. All right. So what we've done so far is create a 9 terabyte dynamic stripe pool, effectively RAID 0. But in case you're not necessarily all that comfortable with what that means, just imagine that we created a 3 kilobyte file on the /geek1. So a kilobyte would automatically go to SDB, kilobyte to SDC, and a kilobyte to SDD, all of those disks. Then when we go to read the 3 kilobyte file, each hard drive would present a kilobyte to us, combining the speed of the 3 drives. Right, so this makes writing and reading data really fast, but it also means we have a single point of failure. Just keep that in mind. So if just one hard drive fails, we'll lose our 3 kilobyte file. Now, assuming that protecting your data is more important than accessing it quickly, let's just take a look at some of the other popular setups. So first, we'll just delete the zpool that we created so we can use these disks in a more redundant setup. $sudo zpool destroy Geek 1. Bam! There goes our zpool. Now this time, let's use our 3 disks to create a RAID Z pool. So RAID Z is basically an improved version of RAID 5 because it avoids the write hole by using copy on write. So RAID Z requires a minimum of 3 hard drives, and it's a sort of a compromise between RAID 0 and RAID 1. In a RAID Z pool, you'll still get the speed of block-level striping, but will also have distributed parity. So if a single disk in your pool dies, simply replace that disk, and ZFS will automatically rebuild the data based on parity information from those other disks. Now, to lose all of the information in your storage pool, 2 disks would have to die. So to make things even more redundant, you can use RAID 6, RAID Z2 when you're using ZFS, and you're going to have double parity. How do you accomplish that? Well, we can use the same zpool create command as before, but what we'll do is specify RAID Z after the name of the pool. Goes like this. $sudo zpool create -f geek1 RAID Z /dev /sdb /dev /sdc /dev /sdd. All right, so what you can see here is df-h will show that our 9 terabyte pool has been reduced to 6 terabyte, right? Since 3 terabytes is being used to hold the parity information. So with zpool status command, we can see that our pool is mostly the same as before, but it's using RAID Z now. All right. Now, to show you how easy it is to just add more disks to the storage pool, let's add the other 3 disks, another 9 terabytes, to our Geek 1 storage pool as another RAID Z configuration. $sudo zpool add -f geek1 RAID Z /dev /sde /dev /sdf /dev /sdg. And here's what we end up with. Awesome, well done. Now you know Z file system setup and what you can do with it. Well done, well done. So guess what? Yeah, there's always something new to get to. I'll see you in the next video.